Assalamu alaikum. Hello guys, this is the screencast for the sixth lab that we had previously in the previous week. We are going to discuss in this video a list of tuples, and we are going to see how to calculate the mean, median, and the mode. In this video, we're going to see how to calculate only the single mode. The multiple mode is going to be in the following video, which is lab 7, and we are going to see the most important thing by the end of the lab, which is creating a frequency table. And this is essentially the most important requirement that you need to know and understand how to do regarding your programming question that will be included in your assignment. Okay, so without further ado, let's start. We will recap just quickly about what we know so far on the list methods. The most important list method that we are going to work, I believe, is going to be append and sort. That's why it's included in this recap. And remember that in order to append, you might not have the list to be as empty list. You can append to actually a list full of elements, but let's say that in this example we have an empty list called names, and you do not recognize a list from its from the name. This name on the left hand side is just a variable name. You recognize a list using by looking at the brackets, the symbols that creates this container or the list. Whenever you see square brackets, you know that this is a list. Whenever you see a parentheses, an open parentheses and a closed parentheses, you know that this is a tuple. Shortly, I'm going to discuss what curly braces mean in Python. It's called a dictionary. We never talked about it because I didn't want to like stuff the lab, because we only have like 1 hour and 30 minutes, or 1 hour and 40 or 50 minutes maximum. So I don't want to stuff the lab when I was illustrating stuff inside the lab. But in this video, I'm going to briefly discuss what is a dictionary, and we will meet the dictionary actually in the part when we start talking about the mode and the frequency table. But just to continue, we have an empty list called names, and if you want to append any element inside names, you say the first the list name first at the beginning, and the list name, it happens to be names in this case. So you say names dot the list, then dot. After the dot, you put the method, which is basically append in this case. A method is basically just like a function. It takes two parentheses, and within the parentheses of this method, you provide the element or the value that you want to append inside the list on the left of the method. Okay. So say you're appending Ahmed, you say you're appending Zayed, so you're appending Barry. By the end of the day, if you print names after the three appends, you're gonna see by the order of appending Ahmed, Zayed, and Barry. If you do not remember this, please refer to Lab 4, where everything regarding the list methods has been illustrated. Now, the third, or the next method we have is the dot sort method, and from the name, it sorts the elements of the attached list on the left, which happens in this case to be names. And if the elements of the list that we are sorting happen to be strings, then the sorting is based on the first alphabet of each string. Now, if the elements of the list that we are sorting happen to be numbers, not strings, like this case, then the sorting will be based by the ascending order of this number. Like the Python or the sort method in Python will sort these numbers within the list on the left from the smallest to the largest, and this is the one that we are going to work on this video, on this lab. Now, passing lists to function, I have talked in details about how to pass a list into a function in the fifth lab in the previous video, so please refer to this section in the fifth lab. I'm not going to do any practical illustrations here in this video, in this recap. I'm just going to show you what this slide is saying so briefly. So we said that we can, like the way we pass a single value into a function, we can pass a list into a function. The most important thing in order to pass a list into a function, see, you have nums, this list here, and you are passing nums into a function called sum_in_list. Okay, so the first step before being able to pass a list into a function is that you define the function that it takes a list, meaning that you need to define the function in a way that it should operate only on lists. And if you look closely, this function definition it works on lists, not only from the name here, not only from the header that we are passing a variable and we are naming it some list or any list or a list. You know that this function operates on list from this for loop, exactly from this for loop. You can tell from this for loop in this function definition that actually this function needs a list to operate on. Now notice if you like passed a single number here, like 2 or something, this is going to throw an error immediately because you cannot iterate over a single number. What does it mean if you say for x and 2 or for x and 3? This doesn't make any sense. So in order to pass, to be able to pass a list into the function, just like we said before, you need to prepare the function in the function definition to be able to accept a list. And how do we do this? By writing some code that operate on a list, for example a for loop that iterate over this list or something. Okay, so in this case I have defined a function, I call it sum and list, which actually gets from the name, it gets the sum of any given list. And remember, these 3 lines, you will need to copy this 3 lines if you didn't use a function for every list that you have, and this is a very tiresome process. And remember when I told you in the previous lab, if you have like 10 lists that you want to get the sum of, you will need to copy these 3 lines 10 times, and every time for each list you're going to say for xn, for example list 1, for xn list 2, for xn list 3, and this is an endless process and this is not efficient at all. So instead of copying or repeating yourself or repeating these 3 lines for every list that you face, just get the common lines where they are actually these 3 lines. Get these common lines that actually get repeated or copied every time you have a list, and put them in a function, and have the function now as a template. Now this template accepts any generic list by meaning that you are indicating here that you're accepting some list, any list that the user will provide. And this templates, once you call in this part, you call the function by its name, which is sum and list, and you pass it any actual list, a list with actual values. Okay, you pass it an argument. So I'm passing an argument of this list that is called nums. What happens is this function definition is defined like this. This is the same exact code right here on the left. When you call line 3, okay, when you call, I think it is not line 3, it's line 5. So when you call line 5, what happens is Python takes the nums list and it substitutes the definitions placeholder, which is the generic name that we have provided here, with the actual list that we have passed, which is names or nums in this case. So you are passing nums. When you are calling this line, when this lines execute, Python takes the nums list and substitutes it with the placeholder within the function. It goes back to the function definition where this function is defined, where sum in list is defined. Okay, it goes back to the definition right here, and it takes the past list that you have given, which is nums, and it substitute the placeholder or the generic list that you have put inside your definition. So it replaces the past list with the generic. So it puts nums inside some lists. So now what happens inside the definition is that Python execute the function definition with the given or past list. So it actually have now nums of 10, 20, 20, and 5, the same exact values as the nums here. Okay, so it start executing some list that is equal now to nums that is equal now to 10, 20, 25, and executes these lines accordingly. Okay, so it gets the sum of these given list, which is nums in this case. If you do not understand what I've just said, please refer back to the, I believe it was the last 20 minutes of the previous lab, the last 20 minutes of the 5th lab. It contains every detail about this part, or about passing lists into functions. Now let's start our new lab. Our 6th lab starts with something called list of tuples. What is actually a list of tuples? Let's consider that we have this 2 lists right here. We have a list called course numbers, and we have a list called course names. Now we've seen something like course numbers so many times before. Course numbers is just a list of numbers. So if you want to iterate over any list, let's say that we want to iterate over this list, and the purpose of iterating over the elements of this list is to print every element, then we would simply say that we need a for loop to iterate through each element inside course numbers. Come on, like this. And what do we do when we iterate? Maybe the purpose for this iteration is, yeah, there is an end here, to print every element of this course list or course numbers list. So let's say print x. Now we get to see the elements of course numbers printed in your terminal. 101, 201, and 301. Okay, so let's say that we want to get the third element, which is 301. So you basically say the list name, which is course numbers, within a for loop and give it a square bracket, and the index of this element is 012. So you give it a 2 and you have 301 printed one more time. Remember, this was from the loop print and this was the print out of the loop, which is by the accessing of the list. Now the same thing goes if we have a string list or a list of strings. Okay, if we have a list of strings and we want to iterate over this list of strings, you say the same thing. You say a for loop for x in course names in this case, and you want to print each element, so you say the same thing, print x, and you get these three elements from this course names. Now let's say that we want to get the third element as well, which is at index of 2 from this course names list. So you say course not numbers, now it is course names, but the index is going to be, its index is going to be the same thing, it's going to be 2. Now this is going to get you operating system, oh there's an s missing here. Now this is going to give you operating system printed one more time. Okay, now with this knowledge, let's say that we want to create a list that contains a list of pairs, and what each pair should include is the following. Each pair of this list that we will create shortly is going to be the course name coupled with its course number. Let's say that we want to create a list that has pairs. This list should be called something like course names numbers, or let's make it in reverse, course numbers names. Okay, see, I have created this empty list like this because I'm not really certain yet what will this list include. Okay, so this list should have pairs. Each pair should be the course name and its number. So let's say the first pair is going to be database and 101. The second pair is going to be pen testing course and its number is 201. Operating system 301, like this. So in order to make pairs, we have one of two methods. We can say that we will make the list of pairs to be list of tuples or either list of lists. And I'm going to illustrate list of tuples. This is what we are going to make because list of tuples is basically something that we will see shortly in an output. There is a function that we will use when we will calculate the so-called mode and the frequency table that will return a list of tuples. That's why we are going to stick to list of tuples. Okay, I just want you to remember the shape of how a list of tuples looks like, because this is going to be really important in the next section. But I'm going to show you how can we make a list of lists and a list of tuples. Let's start with the list of lists. So we have the main list here. Okay, so the mini lists or the inner lists, the first inner list is going to be, we said, the course number and the course name. So 101 and database, for example. So let's say 101 comma database. Now a very quick question. This list, how many elements does this list have? Well, if you said 1, then you got it correctly, but if you said 2, then I don't think that this is really the case here, because remember, this is the main list, which is course numbers names. Okay, so course numbers names has a single element, which is in this case this inner list. Now this inner list itself, how many elements does it have? The inner list itself has 2 elements, indexed 0, 1. Okay, but the main list has 1 element indexed at 0. Okay, this list right here is the single or the first element that is at index 0. Now let's make another list and give 201 and penetration pen testing or penetration testing like this, 201 and pen testing. distinct. Okay, let's make another list like this and give it 301 an operating system. Okay, now this is a list of lists, right? I'm going to do the same thing, but I will use a tuple now. But before I make a tuple, just know that this list right here, which is called course numbers names, now it contains three different elements. Okay, each element is a list itself. Each inner element is a list, and each inner element has two elements, 0 and 1, 0 and 1, 0 and 1. Okay, and the list itself as a whole has three elements indexed from 0, 1, 2. Okay, now what we will be working on, not list of lists, for the purpose of the upcoming section, we need to know how can we make a list of tuples. And list of tuples are basically one of the most frequent returned structures that you're going to see a lot in Python. So you need to actually get accustomed to see a list of tuples. Now, the only change that I will make to in order to get a list of tuples is to change each inner element. Instead of having the inner elements as lists, we are just going to create them as tuples. Okay. Now we don't really need the list of lists anymore, and this is the one that we need, the list of tuples. Now, course numbers names contains three elements. It's the same concept as before. It contains three elements. The first element is index 0, 1, 2. Each element is considered or consists of two elements. Each tuple have two elements like this. Now each tuple has two elements that is indexed 0, 1. This tuple has 0, 1. This tuple has 0, 1. Now what if we want to iterate over this list of tuples? Remember, it's the same concept of iterating over any list. Okay, but I'm just going to keep this at the end. Let's see the most obvious things. How can we access elements in this list of tuples? Okay, let's say that we want to get the first element, which is 101 database, the first tuple. Okay, so you say print, and you put inside the print function the list name, which is course numbers names, and you give it the square bracket. Inside the square bracket, you put the index of this element of this tuple that you want to retrieve, which in this case it is 0, right? So if you run this, you're gonna get the first tuple, which is 101 database. Okay, and what if you want to get 301 operating system? Yeah, which is basically the third element in this course numbers named list, which is at index, if this is 1 and this is 0, 1, this is going to be 2, right? So just modify the index to be 2 and you get 301 operating system. Now the newer question is, what if you want to get database, only database? You don't want to see the tuple of 101 and database, you just want to see database. So how do you do this? Now if you looked closely, you will see that database is located at the first tuple, right? Which is the first index, which is at index of 0. So if you printed this list when it has the index of 0, it's gonna give you this first tuple, just as we did before here. Okay. Now the new thing is, how can we, from the returned tuple that is like that, how can we access the second element of this tuple? Now remember that each tuple has 0 and 1, 0 and 1, 0 and 1. How can you get the second element of this tuple? Now notice something. This whole part here returns this tuple. When you say from this tuple, you're telling Python, from this tuple, please get me the second element. You just need to provide another layer of access. You just need to write something like this. You put a square bracket and you're saying from whatever tuple that is returned, which is in this case the tuple at index 0, which is this tuple, get me the second element of this tuple, which is at index of 1. So this look right here, or this statement right here, will get you the next element of this tuple, which is in this case database. So if you run this, you're gonna get database. This is what we call double indexing or accessing. Okay, and just a note here, what I have done there, this is called the list of tuples in Python, like in Python conventions, but in most programming languages this is called 2D array or 2D lists. Okay, two-dimensional array. Okay, why is it called two-dimensional? I guess that you can guess it right now. Two-dimensional arrays are named two-dimensional because you have one layer of accessing. This is what happens first, and you have another layer of accessing because the first access that you do actually returns a structure, returns an iterable that you can actually access one more time. So the returned iterable, which is in this case a tuple that is returned from this part, you can actually access it again to get whatever you want to have from this iterable or from this returned tuple. So I'm accessing it one more time using the second square bracket that I have provided within this with this index in it. Okay, to get the first index or the index of 1, which is the second element. Remember, this is 0 and this is 1. Okay, so there's some mini programs that I've made for students to make inside the lab practically, and one of these programs was getting the course number 301. Now remember that 301 is located at the third element of this whole or main list, right? So the main list here is course numbers names. So let's just copy this, and let's say that the first access I want to get to the tuple that contains 301, which is at index of 2. Now you have the tuple, right? Get 301, which is the first element of this tuple, which is at index of 0, right? So if you run this, you're gonna get 301. The same thing goes for operating system. Let's now say that you want to get operating system. The operating system is located as the last tuple, which is at index 2, but the second element of this tuple, which is at index of 1. Okay? Now, let's get back to the idea when we say that we want to iterate over these elements. And remember, when you hear iterating, you always need a for loop, okay? Just get this stuck in your mind. Iterating over a collection of elements, meaning that you are using a for loop, any kind of loop. It doesn't have to be a for loop, but the easiest one is obviously a for loop in Python. Okay, so if you want to iterate over this list, just like iterating over any list, say for x or for I for any variable in the list name. So with the same exact fashion, we can say for x in course numbers names in this list name, right? Now, there are two methods to iterate over a list of tuples. Okay, this is a list of tuples. So iterating over a list of tuples have two ways, or have two techniques, to be frank. The first technique that's going to be illustrated in this video is basically, I'm going to illustrate the two methods. Okay, let's just have this here. Okay, so as I was done in two different ways. I believe there are some groups that I have given them only the first method because it was the easiest one. And I remember when I tried telling you the next method, it was kind of confusing. So I told you, if you understood the first method, then just neglect the other. That's it. In this video, I'm going to go full force. I'm going to get to illustrate the both methods. And one of them, if one of them suits you, then just use it. Okay. Now remember that when we created the list of tuples, notice how I created the list of tuples manually. Like I said that I'm going to create at the beginning an empty list. Yeah, inside this empty list I created at the beginning, I said that I will make a list of lists. Then I created a list of tuples, but I made everything manually, and this might not really be handy when you are programming. There is an automatic way, or a very efficient way to create a list of tuples automatically without creating this whole pair thing manually. It's called the zipping function, and it's going to have a video on its own. I believe it's going to be released after this video or uploaded after this video. So let's take the first method in iterating over a list of tuples. Now, as I told you, you need a for loop for x in the list name. Okay, what will happen if I say print x? Notice that x that has been printed is basically each element. Remember when I told you, when we say for x in course names, I told you that x is basically each element of this course name. That's why when we printed for x in course names, we saw something like database, which is the first element, then x, the for loop iterator, got to be the second element, and it was printed, which is pen testing. Then x in the third iteration got to be the third element, which is operating system, and then it got printed. That's why we saw operating system in the terminal. So the same thing goes for a list of tuples. Only difference here is that each element of this list of tuple is a tuple. Okay, each element now is not a string, not like this case, and is not a number or an integer, not like this case. Each element in this list is considered as a whole tuple. Okay, so x is the first element in the first iteration, so it gets printed, which is the first tuple. X is the next tuple in the next iteration, which actually gets printed. Then in the third or the last iteration, x is going to be the last element, which is the last tuple. That's why you see 301 operating system got printed in your terminal. Okay. Now notice something. The for loop actually minimizes the number of accessing. Remember when we need to manually, without a for loop, you want to get individual element. See what we did there in order to get, for example, database. First of all, we have this bigger list. We have the main list, right? And we access the main list to get the tuple itself within the first brackets, right? Within the next pair of brackets, I manually wrote here 1 to get the next element or the inner element of the tuple itself. Okay, so we potentially made something like double indexing or double accessing. The first accessing was to access the tuple itself from this list. The next or the second access was to access the element itself from this tuple, from the returned tuple. So if you're not using a for loop, and this is really important, if you're not using a for loop, you will have double layer of accessing. Okay? But if you are using a for loop, notice something, that when you say for x in course numbers, when you print x here, x is directly the tuple itself. So it's just like saying that the for loop has minimized the number of accessing that you need to do. It accessed the main list, and this is the point of saying for x in course numbers names. When you say for x in any list, Python actually access this list in order to get you the elements inside. So the first layer of accessing to get the tuple itself, it is done using this header right there. Okay, so this header actually minimizes the first or subtracts the first accessing operation. Okay, so now you should know that x itself is directly the tuple. When you say for x in list of tuples, the x itself is directly the tuple. Now with this knowledge, if you want to get from each tuple, which means from each x in this list, okay, from each tuple which is in this loop is x, you want to get from each tuple the first number, 101, 201, 301, like this. Okay, now notice that this tuple is x at the first iteration, and the next tuple is x also at the next iteration, and the third tuple is also x but at the third iteration, right? So from each tuple, from each x, you want to get the index of 0 to get the number of the course, right? So you can say something like this. From each tuple, which is x in this case, from each x, get me the first element, which is at index of 0. So you're going to have 101, 201, 301 printed beneath each other, like this. Now let's say that we are going to make another loop to access not the we are making another loop to access now we access the first element of each tuple. Let's say from each tuple now we want to access each course name, which is at index of 1. So you're gonna say from each tuple, which is x in this case because we are inside the loop, we're gonna say x of 1. So run this and you're gonna get the course name of each tuple. Alright, now what if we want to have the course names and the course numbers alongside each other? So you're gonna say x of 0, which is the course number of the current tuple, and from the current tuple get me also x of 1, okay, which is the course name of the current tuple. So for the first iteration you have this tuple, which is x. You take from x, or the first tuple, 101, which is x of 0, and you take from the same tuple database, which is x of 1. The next iteration continue. Now x is the next tuple, the second tuple. From the second tuple, which is x in this case, get me x of 0, and then get me beneath next to it, get me x of 1. The third tuple, etc. Okay, and you get something like this. Now, why am I showing you this kind of formatting? It is because the first program basically is telling you to create something called a table. You need to create a table. This table needs to be printed in your terminal. And if you look closely, there is some kind of formatting in this table. And formatting is basically done in Python using something called if strings or any string concatenation method, and it really relies heavily on slash t's. If you remember, there's a slash t here. A slash t is basically a unified spacing system. When you do something like slash t, you have this space. Double slash t, you have like two double spaces, two double white spaces. Okay, so in order to do something like this, notice that we have accomplished the course number alongside with its course name to the next of it. This is what we have done so far right here, but without the spacing. There is no spacing, and there is no header of the table yet. There's no equal signs here. So in order to do this formatting, we can do the following. I'm going to leave this there. It won't harm. But let's say that the header of the table is saying course number. Then there is a space, and this space isn't actually done like this. Okay, it is done using the special characters, which is backslash t and course name. Okay, now let's start our for loop, and remember there is an equal sign. There is a bunch of equal signs here. Okay, so let's say equal signs like this, and this is really dumb. Instead of doing this, you can do something like an if string like this. Say if string, okay, and equal sign, right? And instead of equal sign, all right, and multiply this equal sign by 30, for example. Okay, so it's gonna get you like 30 equal signs, or I don't know, maybe 50, whatever you find it. Oh my god, this is too much. My 50 like this. I think 30 is kind of accepted. And instead of like spamming your code with like 30 equal signs like that. Okay. Now we're gonna make a for loop, and let's say for x in course numbers like that. And let's say that we are going to print, but using if strings. Remember that if strings was in the first lab. Please check the document of the first lab. Okay. So at the beginning we will put x of 0, which is the first index or the first element, okay, from each tuple, which is the course number. Then next to it we're going to make backslash t, then a curly brace one more time, and put x of 1, which is the course name of each tuple. Okay, if you run this, you're gonna see that you have a backslash t, which is not basically aligning with the header, not basically aligning with the columns. So you need to push this a little bit further, which is the second column, which is the x of 1s. So let's make another \t. Notice that this is a process of trial and error. You just, in formatting, this is what you do. You keep on modifying your code until you see an accepted format or an accepted output format in your terminal. Okay, so this is the table that we have seen in the program 1, right? Now, what I have told you here is the first method. Okay, let's just remove this. The first method was basically using one iterator, just as we have done before. That's our normal look of a for loop. We are always we have been always using the for loop like this. We said for x, which is one variable in whatever the list name will be, right? For x, for course numbers, for x in course number, for x in course names, for x in course numbers and names. And this is the first method. Now the second method that Python actually introduces to new programmers or newcomers is saying something like this. Do not freak out, okay? It's really easy. Let's say something like for x in course numbers names, and you might think that it's the same header here, so what actually has changed? Now let's just look closely now. If I said something like for x comma y, right, and if I printed x and y, let's see what happens. Notice something? Now x comma y is basically a way of unpacking each element. You're saying that x, remember, when you say for x in course names and you print x, what actually gets returned is the tuple. So Python now knows that this list is a list of tuples. So if the elements of the list that you are iterating are tuples, okay, let's say that these tuples are of 2 elements or 3 elements or 4 elements or whatever, okay, if they are, let's say, tuples of 2 elements, then you can actually prepare 2 iterators in the for loop header to unpack each element of these 2 elements of the tuple itself inside these 2 iterators. So now you're saying if you have 101 and database, which is the first iteration, right? This is the first element in this list, right? This is the first iteration, okay? So you're saying instead of putting putting the whole tuple inside one iterator, you're saying now that you are unpacking the tuple to 2 different iterators. So you're saying if this is your first element, if this is your first tuple, unpack the first element of this tuple into x and unpack the second element of this tuple into y. Okay? In the next iteration, when this is your element, the element that the for loop is iterating from this list, when this is your element, Python will see that you are unpacking the 2 elements of this list into 2 different iterators. So now, with the same exact fashion, the first element of this tuple will be unpacked into the first iterator, and the next element of this tuple will be unpacked to the next iterator here, which is y. Okay, so you need to understand that you are iterating into or through a list of tuples, right? And if you're iterating over a list of tuples, you should look closely at your tuples. If the tuples are of 2 or 3 or 4 elements, you can prepare as much iterator number or iterators in your for loop that equals to the number of elements of the tuple. So let's say that the tuple has, every tuple has 2 elements. Okay, so prepare 2 iterators. Okay, each iterator by order will take each element of this inner tuple. Okay, so x in the first tuple is going to be 101, x in the next tuple is going to be 201, x in the third tuple is going to be 301, and y in the first tuple is going to be database, in the next tuple is going to be bin testing, and in the third and last tuple is going to be operating system. So with this order, x will always be the first element in the tuple. So if you print x is going to be only the numbers of each tuple, and if you print y, it's going to be the course names of this tuple. Now, if you replace them saying something like y and x, the order really matters here. So y now is the first element of each tuple. So if you print y, you will get the course number of each tuple. And vice versa, if you printed x, is going to get you the course name of each tuple. Okay? Now, when we are using something like this, when it is only one variable, it is really it's irrelevant. If you want to name this into, I don't know, you can name this into tuple and just to tell yourself that you are iterating over a tuple, or you can just leave it x, m, whatever. But when we are unpacking the tuples into iterators like this, in Python it is a very good programming practice to unpack the elements into meaningful variables. So instead of me having y and x, I can say something like num or number and name, which actually means that the first element of each tuple that I am iterating is always going to be a number, right? And the second element of each tuple that I am iterating is always going to be a course name, right? So that's why I'm having this as number and name. So now print number and print name next to it. It's going to get you the same exact result as the one that we have used x of 0 and x of 1 in. Okay? Now, if you want to use the same exact if string technique, let's just take this table header and the equal signs, and let's do the same thing. If string curly brace number /t and name. Now run this. It's the same exact result. Okay, so the first method is using one iterator or one loop variable. Okay, and hence the one loop variable, which is x in this case, is the tuple itself. You can say that if you want to get the first element of the tuple, you say x of 0. If you want to get the next element of the tuple, you say x of 1. The next method, if you understand this, that's fine, this is good. Okay, if you do not understand it, or if you want to use the next method, which is basically, in my opinion, it's more readable. Okay, so the next method is basically using one more time, is using two iterators. What's going on? Is using two iterators, okay, which is two for loop variables. Oh my god, the universe is against me today. Is using two for loop variables. Okay, if you understand both of them, then this is really good. If you want to use one of them, it's up to you. Okay, now the automatic way of creating a list of tuples, this will be in a separate video. Okay, so if you get this so far, then that's really good. Okay, now let's see program 2. Program 2 is telling you that you have a list called list1, and it has these elements, and it's asking you to make a function called calc mean. This calc mean accepts only one argument, which is basically any generic list like this, and it should return the mean or the average of the given list, which is in this case the program wants you to work on list1. So I'm just going to copy. Okay, this is really lame. Sometimes it glitches like this, so this is fine. It's because of the web application. So let's make another script and call it trial 2 by, I don't believe that there was a trial 1, but whatever. Okay, so now let's have list 1, right? And list 1 has 30. So the summation of if everything is going to be 60 over 2, then this should give you 30 by the end of the day, right? So the first step is to define the function. Now we put the definition at the top, so let's say that the function is called calculate mean. Now let's say the first version, we're gonna make two versions of this. Calculate mean should take any list like this, okay, and you have two steps in order to calculate the mean. The first thing, to get the sum of this list, then get the number of elements of this list and divide the sum by the number of elements. And when we say number of elements, I actually mean the length of this list. Okay, so the manual way that we have actually been introduced to in order to get the summation of any list was to make a variable, call it sum, and then make a loop to iterate over this given list, which is in this case we named it any list. And then once we start iterating using the for loop, let's say inside the loop sum equals sum plus x, and by the end of the day return sum. Not exactly, we should return sum over len of any list. Okay, this is going to return the average of these elements. Now let's call this function, which is calculate mean, and give it list1 that we have prepared here, and let's just print whatever value that's going to be printed or returned from this function call. Now run this. You should see 20. Did I say 30? Yeah, no, I'm sorry. It is 60 over 3. Yeah, 60 over 3. So it should get you 20. I'm sorry about that. Okay, so this is the first version. Now we have another version that we didn't really talk about, but let me just open the shell really quick. Remember when I told you that you can actually test stuff here in the shell? This is what I'm doing right now. So let's say that I'm having a list called, let's not name it X, let's name it, I don't know, list, for example, and have it like these elements. Now, instead of getting the summation using 3 lines like that, sum equals 0, 4 to iterate over the elements, after iteration, now sum equals sum plus x, and instead of having these 3 lines, we have a built-in function called sum. And this sum function is actually built for lists or iterables that contain integers, floats, or any kind of numbers. Okay, so this sum function accepts only iterables. So let's give it, for example, list. So it's gonna get the summation of these elements inside list that we are passing, which is in this case 60. Okay, if you tried calling this built-in function sum and you give it something like sum of 6, it's gonna give you an error telling you that this 6 is an integer, which is not actually an iterable. So I don't know what should I sum. Now, if you look closely, you'll see that how does this sum function works? It works with the same exact fashion as these 3 lines. So your actually default question right now would be, why did you made us go through all of this without? I mean, you could have actually told us that there is a function called sum that actually sums the elements in a given list like this in one line, and instead of making 3 separate lines for every submission that we make. Now, you are partially, you're also partially correct about this, but the thing here in this course in programming, you don't always want to be a user. You don't want to be this guy. You don't want to be the one who actually get the shortcuts. This is not programming. This is the development side. If you want to be a developer that gets the job done in the quickest possible way, in the shortest amount of given or allocated time, then this is the right way to go. Yeah, you have a project and you want to submit it maybe in 1 week or 2 weeks. So you're not going to write everything from scratch like this. So instead, you're going to search the internet for built-in functions or functions that other guys or other people out there or other programmers have built for you, and you're gonna start using them, just like the sum that we are using right now. Okay, so this is the development side. Before you get to be a developer, it is a very important thing to know how to program the functions that you are using as core functions. Okay, having the knowledge of something that you are using is really powerful. Now, you know how does this sum function, how does this built-in sum function works, because we have done this previously. We know that these 3 lines are basically the definition of this sum function. Okay, so that's it. Now we need notice that I'm still inside the shell. So in order to get out of the shell, of the Python shell, just press Ctrl Z, Now we are out of the shell, we can run our program now. So let's say that this is the other version, this is version 2 of calc mean, and instead of saying these 3 lines, we are going to use the built-in function, which is the sum function, and give the sum function any list. Okay. Okay, and there's another side note that I believe I've talked with group 4. I think group 4 were the only ones, Tamer and Yusuf. They were the only ones who raised this issue. They were the only ones who noticed this. Uh, if you look closely, this sum that we have used as a variable, why is it colored in yellow? Why is it colored in the same color that calc mean version 1, that is a function, is colored in? Like normal variables do not are they are not colored in some certain color in Python. They are not highlighted in anything. Let's say that we have m equals 7 or y equal 9. These are normal variables, just like x here. Yeah. So why is sum not highlighted in white? Why is it highlighted in yellow? This actually is an indication that this sum that you are using as a variable is basically a function. Okay, functions, like in this theme that I'm using, for example, Python intend to highlight special keywords, functions, if statements with certain colors. In this theme that I'm using for Python, Python is using functions to be highlighted in yellow. So basically, you could have actually noticed this from the start, like that. This seems not like your average or your usual variable. This variable seems to be something else. It does not seem like a normal variable like y and m. The thing is, the sum that we were using as a variable, and we would say that sum equals 0, the sum equals sum plus x, we were basically overwriting the functionality of the sum function. We were overwriting whatever this sum function is doing, and we are telling Python that forget everything that you know about the sum built-in function and just use it the way I'm using it right now. Just go along with me and use it as a variable that contains a single value. Okay? Now, because this is really interesting, I just want to show you something. And this is actually optional. You can skip to the next segment or to the next program. Okay? Now, I told you that, let's say that we have list 1. List 1 is basically something like this. This sum function, yeah, it accepts any list, so it should tell you that the summation is 100. What did we name it? Oh, there's a T. There's a missing T here. Okay. Now, what happens if you like treated the sum function as a variable, just as we did here? And I have done this only in group 4 with Tamer and Yusuf. Okay. So what happens if we say that the sum is equal 3? Now we are overwriting the functionality of this sum function. You're saying that this sum function is no longer a function. It is overwritten to be 3. That's it, right? So if you print the sum, it's going to give you 3. Now, if you want to reverse back and say that I want to use the sum as its intended functionality, as its initial built-in functionality, which is using the sum as a function, and give it the parentheses and give it something like list 1, it's going to give you an error saying that sum is no longer a function. I don't know. Python is saying that I don't know what you are trying to do. This doesn't work because you have actually overwritten what does the sum actually does. You said now that the sum equals 3, so there's no going back. You can now say that the sum is a function that accepts a list. Okay. If this is not clear, I'm going to illustrate the same thing within this code right here. Okay. Let's say that now my sum is, for example, let's use the sum as a function, which is its actual functionality. Okay, and let's print whatever value that this sum will return. Yeah, now run this, it's gonna get you 60. Now let me just do something like this. Okay, let's say that I am overwriting whatever the sum was intended, what was intended to do from the start. I'm overwriting whatever the sum was supposed to do, which is summing the elements of a given list. Okay, and I'm trying to print whatever inside the sum right now. Okay, now notice something. See this warning? It's telling you the sum is not callable. Sum is not callable. This means that sum is not treated as a function anymore. Python is saying that it cannot call this function because this is not a function anymore. You changed how the sum operates. You changed how the sum internally behaves. You said that now sum is equal to 4. So basically, sum, even if you look at this hover here, it's saying that the sum contains an integer. Sum is not a function anymore. So Python now is confused because you have overwritten this with a number. Then you're saying that you want to go back and use it as a function, and this is not acceptable. And if you run this, you're gonna get to see 4 printed, which is the first print, and when it tries to execute the 21st or the 21st line here, it's gonna get you this error because this sum that contains an integer is not callable anymore. It's not a function. Okay, but notice something. If I remove the sum equal 4, and if you run this, Python is going to get you the result, which is the summation of this given list. So the sum function will work just as usual, just as before. And this is one of the key features in having to work with a dynamic language like Python or JavaScript or MATLAB or Octave. That's the beauty of having a dynamic language. A dynamic language is basically, it's called dynamic because of this. Remember when I told you at the beginning of the lab, or I told you this also in Octave in the last semester, I told you that you can say that x contains 3, and at some point in time you can say that x now is a string. Yeah, you're reassigning x with a total different thing, a total different value, and now you can say x is like overwrite everything and consider x as a list. The same thing goes not only with normal variables, the same thing goes with any defined or built-in function. Okay, I mean this section, all of this was an optional overview. I just wanted you to understand what was happening, what are the things that you are doing, and what does it mean. Just not to be like ignorant of everything that you are doing. Okay, so there is, I believe I will put a label here in order to skip whatever this optional section is saying and just go right ahead to executing the next problem. Okay, so these are, let's go back to what we were saying. These are the two versions, version 1 and version 2. Okay, now we can calculate version 1 and pass it list 1, and we can calculate version 2 and pass it also list 1. And we will need to say print like this and run, and you're gonna get the same result. Okay, so let's see the next problem. Okay, so I remember this was an in-lab challenge that I gave you like 10 to 15 minutes to try and solve by yourself without me trying to explain anything. The algorithm steps was basically in front of you. I just told you that you need to look at the steps, read it carefully, and try to understand the example or the case scenario that you have. And if you remember correctly, I told you in any exam, in any programming question, whenever there is a case scenario like this, whenever there is an output, an example on the output, like this in this case, this is the most important given that you need to work on. Okay, case studies, whenever someone gave you a case study like this or an output of example of the output, how should the output would be, basically the one who writes this question is giving you a hint of the solution. You just need to figure out how to reach the solution using this hint or this case study like this one we have here. Okay, so I told you have this algorithm walkthrough. Just read the steps, try to understand it by yourself, and eventually you get the solution. Now, in mathematics, it is really simple if you want to get the middle of the number that is in the middle of any list, which is the median. You just look at the list, you sort them, and you say that the number in the middle is, in this case, for example, is 30. It's really simple, right? Well, it's really challenging when this is when this is converted to a programming question. The challenge here is not your understanding to math. It's like mathematically, this is really easy for you. You sort them and you say that the element in the middle, that is the median. Okay. The challenging part is how can you convert your understanding? How can you convert or translate your understanding or the concept in your head, which is sorting a list and picking the element in the middle. Yeah, that's it. How can you translate this to an actual code? How can you translate your understanding into a code that you will write on Visual Studio or any editor? So that's actually the main challenging part in any algorithm or in any programming question. Okay, and this, just believe me, this will come to you eventually with time, with training and time. Give yourself time to practice something. Do not always look at the solution. Look at multiple solutions on the same programming questions on the internet and see how different people thinks and how different people approaches the same question. This will enhances your understanding to so many things. So to get the number of the middle, the first step, as the algorithm is saying, is to sort the list. And sorting the list is really simple. You say that you have this list, for example, right? So a list dot sort, it's done. You have sorted the list from the lowest to the greatest. Now, the second step is the little bit hard, or the hardest step, if we can say. The second step is actually to check if the length of the elements is odd or even. Now, before you get to say that the element in the middle is 30, you need to check if the number of elements of this list was odd, then it is obviously the element in the middle. Okay, in this case, the number of elements is 5 elements, which is an odd number of elements. Okay, so basically the element in the middle is the median. So how can you get the element in the middle? Now, notice that in this question you are giving this example, this list as an example. You need to use whatever you can gain from this given. Now, this given, which is a list, there is a very important piece of info that you can take out of this list, which is basically the length of the list, right? So let's say that we will get the length of this list, which is going to be 5, and basically the length of the list is our condition in the if statement. This is what we will be comparing on, right? So if the length of this list was an odd number, so get the element in the middle. If the length was an even number, so get the average of the two elements in the middle. Okay, so let's start by copying this list here. And let's make another script. It's called try1. I will not do this inside a function. I will do it first without using a function. Then I will put this inside a function, right? So we have a list like this, right? The first step was sorting the list. So we say a list dot sort. Now let's print a list. Run this. The list after sorting is looking like this: 5, 10, 30, 80, and 90. The element in the middle, this is the median. But how can you get the element in the middle? Now, if you look closely, after sorting, the element in the middle is at index of 2. And this is a very important piece of info that you need to work on. How? Now, what do you know so far? You know that you can get out of this list, you can get the length, right? So let's get whatever piece of information that we can get out of this list, right? So let's say that we have the length of a list, right? Okay, so what does this return? In this case, it returns 5 because we have 5 elements starting from 0 to 4, right? Now, what we want to do is to make an if statement. We should now, after the sorting, we should check if the number of elements is odd even, right? So we say if the length of this list, if the number of elements of this list, when you divide it by 2, if it gives you an odd a1, so this means that the length is an odd number, and this is true. This is going to yield to true, and this if statement will be executed because we have a length of 5 here, right? So remember that the length is equal to 5. Something is missing here. Okay, so the length is equal to 5. Now, what we can do now, all right, we know that the length is 5. How can we get the element in the middle, which is 30? Now, let's see how can we use the length. The first usage of the length of this given list was to check if the number of elements is even or odd. Now, there is another usage to this length property. We can say that what happened if we divided the length by 2, right? We have the length, which is 5, right? Divide 5 by 2, it should give you 2.5, right? Now, if you cut the 0.5 or the fractional part from this fraction, you have 2 remains, right? And let's consider that we have 3 elements. So the median is at 1, right? So 3, which is the length, over 2, this gives you 1.5. Now cut the fractional part, you have 1, which is the median. The same thing goes for 5 elements. 5 over 2, 2.5. Cut the fractional part, which is 0.5, you have 2, which is the median. This is the trick here, okay? So we are using whatever piece of infos that we can get from this given list, right? This is the point of making a case study on something. All right, so now we have length of a list. Now let's say that length of a list, I'm going to use it again and divide it by 2. Now remember that dividing length of a list will yield 5, right? 5 by 2, this is going to get you 2.5, right? And remember, after sorting, this is our list that we are working on. After the sorting, this what get printed. Okay, so basically the median is at index 2, right? So if I was able to convert 2.5 to only 2, then this will be my index of median, right? So in order to cut the fractional part, remember there is a function called int that we were using from the start of the semester. We are just going to cast whatever that's going to be resultant from this operation, which is len of the list over 2, which is 5 over 2. This highlighted thing is going to give you 2.5. Now if you set int of or cast this value, which is 2.5, into an integer, the fractional part will be removed like this. So we will be having 2 by the end of the day, right? And this can be stored in a variable. Let's call it index. Okay, so now we have the index in our hands, right? And this will actually work on anything. Now we have the index itself, but we do not have the median, because if you printed the index, that does not mean anything, because this is just printing the index, the position. We want what lies under this position, what lies under this index, which is 30. So basically we can say that the median is equal to, from this list, get that index, which is in this case is 2. So this is going to get you, when you by the end of the day print median like that, it's going to get you 30. All right, now let's try to work on another list. Call it, or let's make it the same list, but just let's minimize the number of elements. Let's make them, for example, let's remove these guys. So if you run this now, the sorted list is 5, 10, 30, right? So basically the element in the middle, which is in this case 10, is at index 0, 1. This is the index of 1. This is my median, right? So it also, the same concepts works the same way. Now the length is not 5, it is 3. When you divide 3, which is the length of this list currently, on 2 or over 2, this is going to give you 1.5. Now if you said integer or cast whatever is resultant from this operation, which is 1.5 into an integer, the 0.5 is going to be removed. Okay, so you will have by the end of the day 1, which is the index of the median, which is really, that's true, that's correct, it's 1. 10 is at index of 1. So when you say index, which is 1, when you say from a list get me the index of 1, it's going to get you the median, which is in this case 10. So we can say now that we have successfully done the first part, which was basically basically working on the median when we have the number of elements of the list to be odd number of elements. Okay, now the second part, which is checking if the length or the number of elements were even, which is the else statement. Now if you look closely into your case study here, or case scenario, you're gonna see that we have now 6 elements. We have added, I believe, 90 at the end. Okay, so after sorting, we will see that this is the sorted area, or the sorted array or list. Okay, so when there are even number of elements, the median is basically the 2 elements in the middle. Okay, the mean of the 2 elements in the middle. Now what we have accomplished so far is, what if the list has an odd number of elements, which is this if statement. But what if the list has an even number of elements, which is like this else right here. Let's say that we will add like another 90. So basically this if will not work because the length here is not going to yield an odd number. So this if will not work. So we need to work on the next probability, or the next case study, which is basically having an even number of elements. Okay. Now, if we have an even number of elements, then basically the mean or the average of the 2 elements in the middle is your median. Now let's say that we have added another element like this 90 at the end. Now the sorted list is like this, right? So you have 6 elements, notice from 0 to 5. The elements in the middle, the 2 elements in the middle, when you sum them together and divide them by 2, you get the median. Okay, the mean or the average of these 2 elements is your median. But how can we do this? Now remember this trick that we have used when we divided the length, when we were dealing with the odd number of elements list, and we divided the length, which was in this case in the first if statement, it was 5. We divided 5, which is the length, by 2. It yielded 2.5. And we casted the 2.5 into 2, then we ended up with the median, right? We can do the same trick. Let's say that we have the length, right? Come on. Now let's say that we will use the same length trick. So let's say length of a list over 2. Now remember, the length is 6 elements. Okay, these are 6 elements. So basically, this is dividing 6 by 2. So this will yield 3. Okay, and remember, we are talking about indices. We're not talking about the element itself right now. So if you look closely about what is that 3 from this case study or from this example, you will see that 3 is the index to the right. You see, you have 2 elements in the middle. One of these elements is to the right, which is 80, and one of these 2 elements is to the left, which is 30. The element to the right is the resultant of dividing the length by 2, which is in this case 6 over 2, which is going to give you 3. Okay, so if you have index of 3, then you have the element to the right. What if you want to get the element before it, to the left of it? Okay, so you just subtract this 3 by 1 and you get the index of 2, which is the element before of it, right? That's the whole trick. So let's say that I'm going to, let's say before this else, I'm just going to print, I'm going to run this. So this is my sorted list, right? Now this is my sorted list, okay? Now the length of this list is 6. When you divide the length of this list, which is 6 by 2, okay, you get 3. And basically 0, 1, 2, 3, okay? These are the two elements in the middle, right? And this 80 is at index 3. So dividing the length by 2 always gets you the element in the middle, okay? Or I'm sorry, dividing the length by 2 always gets you the element to the right, okay? So now you have index of 3, which is 80 in this case. So let's save this in a variable and call it index to the right, or index to right, okay? Now let's try to print this element to the right, which is 80. Let's say that I'm going to access the A list, right, and try to access the index to the right, okay? It should give you 80, right? If you run this, the problem here is saying that the index of any list must be an integer. It does not, or it cannot be a float. What does this supposed to mean is, if you remember what I've told you in the first lab when we were dividing, I told you when you divide any number by itself, let's say 6 over 2, like what happens in this case, for example, what is returned is not basically 3. What is returned is basically 3.0, okay? Python, any division in Python yields in a float, okay? Even if the operands of this division operation is basically integers, even if both of them were integers, no matter what, if you are dividing anything integer by an integer, float by an integer, integer by a float, the resultant will always have a fractional part. That's the thing with division in Python. So if you are passing a 3.0 or any float like this to a list, this will result in an error. You cannot basically do something like this. If you have a list called list1 and have it like that, if you want to access the first element, you would say the list name, and you're going to give it the first index or the first position, which is 0 in this case. Or let's say the next one, which is 1. This is going to give you 20, right? You can't give it 1.0. This is not acceptable. Indices in all programming languages needs to be integers. They cannot be floats, even if the float have a 0.0 fraction part. Okay, so you're gonna find yourself in the need of the integer casting again in this else statement, in this else condition, right? Because we don't want to use the 3.0, we want to use the 3, the integer, the casted number of this division, which is 3 in this case. Okay, so now this is gonna print you 80, right? Now with the same exact fashion, if you have the index to the right, which is 3, yeah, which is 80, you just need the index before of it, which is 30, which is at index of 2, right? So to get the index before it, you just subtract the index that you got, which is 3 by 1. So let's say index to left, which is, I'm talking about 30 in this case. This is the two elements in the middle that we are looking for. Index to the left, and we are going to say that I'm going to use index to the right -1. Now I have 2, or index 2. Now if you have the index of 30 and you have the index of 80, just get the two elements, add them together, divide them by 2, and you have the median. That's it. So the median now is going to be, from this A list, get me the element to the right in the middle, and from the same list get me the element in the middle, which is to the left, sum them together, and divide them by 2. Okay, now you get the median, which is 80 plus 30. I believe it is 110. 110. So 110 over 2 is gonna get you 55. Okay, so let's comment out this median and let's see the median here. So these are the two elements in the middle. This is the index to the right, which is 3, okay, which gives you 80, and this is the index to the left before it, which is 2, which gives you 30. 30 plus 80, 110 over 2, this gives you 55. Okay, this would work even if you have like 4 elements. Let's say that we have a different number of even elements. We have this 4 elements. Okay, so these are the 4 elements after sorting. So the 2 elements in the middle, which is at index 0, 1, 2, one at index of 2 and the other at index of 1, right? So what's going on here is the length now is basically, this is the list that I'm working on, so I'm just gonna update this part. Okay, so the length here is 4 elements. When you divide 4 by 2, you get 2.0. After the casting, you get only 2, and 2 is basically the index of the element which is to the right, right here. Okay, which is basically is 80. Okay, when you say 2 minus 1, you get the index before of it, which is index of 1, which is 30 in this case. So index of 2 اللي هو 80 يعني, وindex of 1 اللي هو 30. 30 plus 80, this gives you 110. It's the same thing, divided by 2, this gives you 55. Okay, so let's just return everything as it is, and this is our list of 6 elements, and this is the median. Okay, now I'm going to show you how can we make a function out of this. It's really easy. Trial 3.py. I'm just gonna take this in another side and let's say define calc median, right? And calculate median is going to have one list as an argument to be passed into it. All right, and we are going to do everything like this. Just copy these parts and put it here. Indent everything. Just remove the comments if it's bothering you. If you don't want to print the list, it's fine. You don't have to print it. I was just printing this because we need to know, we need to keep track of the list that we are finding the median of. All right, so just remove these comments. Okay, now remember, we are not working on any list, but I don't want to change every a list to any list, so just let's change the parameter itself to be a list, and we're good. By the end of the day, the median that you have calculated, you either can return or print it. I'm just gonna return it, return median, like that. Now this is called the function, and we need to test the function on some list, so let's give it list, let's call this list 1 just to not confuse you. Now let's say calc mean, call the function, or calc median and give it list 1. Okay, and print whatever median that's going to be returned out of this function. Okay, if we passed it an odd number list, it's gonna get you 30. Okay, we can actually include the print of the sorted list just to see what's going on. I think this is important, yeah. So this is the printed list. Okay, this is the median. If you give it like something, now it's still an odd number, so it's basically it's gonna get you the element in the middle, which is 10. Now let's try to give it something like 10. So this is, I believe this is an even number. So I think these are the 2 elements in the middle. 20 plus 10 plus 2, 10 plus 10, which is 20, over 2. This is gonna get you 10. Okay. Okay, so this section focuses on creating a frequency table, but let's just discuss how can we calculate the mode before we jump into creating the frequency table. Okay. So basically the mode in math is basically the most frequent element or the most frequent number in a list. When you look at this list, the mode here is obviously 50. 50 is the number that has the highest frequency in this list. It appeared 4 times, where 11, for example, appeared 2 times, and 1 has appeared 1 time, and 40 has appeared 2 times. So basically, 50 is my mode in this list. Now, in math or mathematically, you need to count every element in order to know which element has the highest frequency or which element has the highest count, right? So when you said that 50 is the greatest, this is because you have counted 11 and you found that 11 has appeared 2 times and 1 has the count of 1 and 40 has the count of appearing only twice. So the element that has the highest number of counts is basically 50. Now, how can we do this in Python? In Python, there is a built-in module that we can import, which can actually count each element and how many times each element will appear. This function is called counter. The function counter is the function that we will use to count each element. Therefore, we will have the element and its count. The function counter isn't one of the core functions. You cannot find it immediately like the print or the input state or the input function that we used to use in our codes. It is located in a library called collections or in a module called collections. Okay, so let's make a new script. Let's call it, I don't know, let's say trial 4.py. So remember in the third lab when we wanted to simulate a die, I told you that we wanted to toss a die for 1 time, and in this 1 time toss, we wanted to see a face, one of the 6 faces of the die, right? We wanted to generate one of the 6 faces, and in order to simulate this, we needed a function that generates a random integer between 1 and 6, and this function was called randint, which basically stands for random integer. Random int or randint function actually takes 2 arguments: the start and the end of a desired range of random integers. But the problem is when you run this, you're gonna get this error telling you that randint is basically an undefined function, or it's not defined there. Python does not know where is that randint function. Unlike the print function, where you used to execute it and run it usually without any errors, because the print function is called a core function, which basically Python knows by default. It knows by heart. You don't need to import or get print from anywhere. It is there. It is there for you. It's the same thing as using the input. It's the same thing as using the int function. All of these are core functions. These are known by Python. But randint isn't basically located at the same place as the print and the input and the int function. It is located in another module, which is called random. Remember when I talked to you about when I talked to you about libraries and modules, I told you that a library or a module in Python is basically a script that contains multiple functions. And from that script, we will always find ourselves in need to get or import 1 or 2 functions, and this is the case here. There is a script or a library called random, which you can find random inside, right? So you just need to say from this library that is called random, import randint. This line, this exact line here, will actually remove this underneath warning that you will face. There is no error there or exceptions that will be thrown right now, because now when you say from this library import this function, it is just you telling Python, please, wherever this function is defined, wherever this is located, please bring it to my workspace. Just put it in my script so I can use it without any problems. Okay, this is what import means. Okay, so now we can say that we will print whatever value that will be generated out of the randint function, and every time you run, you will see a different generated number between 1 and 6. With the same exact fashion, we will import a function called counter. So what does counter do? I told you that in order to get the mode from a list, first of all, you need to count each element in the list, and basically the highest count is, or the element, let's say the element of the highest count is your mode. Okay, so what function does count this? What function does count the elements in a list? The function that we need is called counter. So basically what counter need is basically a list. So I'm just going to get this list that we were working on visually. I'm just gonna put it here, and I'm going to pass list1 to counter. Now what will counter do is that it will count each element, and it will tell you that each element has the specified count or the specified frequency. It will tell you something like 11 has the frequency of 2, and 1 has the frequency of 1, and 40 has the frequency or the count of 40, and 50 has the frequency of 4, meaning that it has appeared 4 times, right? So if you run this, you're gonna find the same error of random integer that we have faced before when we tried to use it without importing, saying that there is nothing defined in Python by default called counter. Python cannot recognize this counter function. So where does this counter function is located? It is located in a library or in a module called collections. Okay, so just as we did here, we will say from module, that is collection, from the collections module or library, import counter. Okay, when you control S or save, you're gonna see that the warning underneath this function will be gone, meaning that now this function is recognized by Python. Python knows by heart that there is something called counter. It can reach it. Okay, it is important to my workspace here. Now, since we don't really need to work on random integers, this was just for illustration. I'm going to remove it. Now, what you need to do is, you should know that counter will return something like this. What counter will do is that it will count each element. All right, so it will count 11. It will tell you that 11, it will count them by the order of their appearance, like what appeared first. It will tell you that 11 has appeared first, right? So 11, it will count 11. It will say that 11 has appeared twice, and next is 1, which has appeared 1, and next is 40, which has appeared 2 times, and lastly there's 50, which has appeared 4 times. Okay, so you need to know that counter will return some kind of an object like this, a structure, an iterable like this. Okay, so since counter returns an object like this, we should save it in a variable called whatever. Call it C, call it X, call it A, just save it in any variable, call it result. It's the same thing, it's just a variable name. Now spoiler alert, or I don't want to make it sound like any spoilers. There's no spoilers here. Just know that this content that I'm going to talk about right now is called an optional content. Remember when I told you inside the lab that the counter will count the elements and will return each number with its count beside of it, like this, without any order. I told you that the counter function does not count with order. It just counts them based on their order of appearance, right? Remember when I told you this? And I told you that since we don't have them ordered from the lowest frequency to the highest frequency, as you can tell here, it is not ordered from the highest frequency to the lowest or vice versa. It's just ordered by the order of their appearance, like what appears first gets counted, right? This is what I told you inside the lab. That's why I didn't want to print whatever is inside C, right? And I'm going to go through this in detail, but I remember that I told you that counter just counts the elements of a past list like this, like list 1, and it counts these elements based on their order of appearance. So what actually sort the counted elements from the highest frequency element to the lowest frequency element. What does the function, or what is the function that does this kind of sorting from the highest frequency to the lowest frequency? I told you that it's a method called most common. So if you remember the 3 lines that we were always using when we used to find the mode of something or create a frequency table of some elements, we used to import, this is the most important line, import the counter function from the collections. We said that the counter will count the elements of a given list but will not order them by their highest frequency or their lowest frequency. It will just get the count of each element based their order of appearance. But when we use this method, which is most common, and remember, most common is a method, so always remember that any method comes with a dot operator or an access operator at the start. And what are we accessing? We are accessing whatever is stored inside C. Whatever is stored inside C that has been returned from the counter function, which is actually this object. So we're saying that please, can you like sort these tuples that have been stored inside C, and can you sort them based on their highest frequency to the lowest frequency? Can you do this to me, most common? So most common will happily do this to you. So it will sort them from the highest frequency to the lowest frequency. So it's gonna return something like this. If you sort these kind of tuples from the highest frequency to the lowest, basically you're gonna have 50, which is the highest frequency element. This will be at the beginning. Then the next highest frequency is going to be 11 or 40. Well, it is 11. Why is it not 40? Since both of them has the same frequency, this has appeared twice and this has appeared twice. It's because of the appearance. Like if they are the same frequency, then the next priority check will be who appeared first. Okay, so 11 has appeared first. Then the next, or the third highest frequency will be 40, that has appeared twice, and the least or the lowest frequency element will be 1 that has appeared only one time. And basically most common returns these tuples inside a list. So basically most common returns what's called as list of tuples, and this what we were working on so far from the beginning of the lab. Okay, now since most common returns something, let's store them in a variable. This variable I tend to call it all frequencies like this. I tend to call it all frequencies. You can just call it X, Y, whatever, but all frequencies is more meaningful since you have every element with its frequency. Okay, so you got all elements with all their frequencies. That's the reason of the naming here. Okay, now if we printed the all frequencies variable, you're gonna see the same exact list of tuples that I've written there. Okay, what has been returned here is a list of tuples. Remember at the beginning of the lab I told you that we can create list of pairs. We can pair a course name and a course number. We can use this pairing technique by using a list of tuples or list of lists. But I told you let's focus on list of tuples because as you have seen here, most of the returned objects in Python is returned as a list of tuples. That's why I was emphasizing on the point that list of tuples are more commonly used and returned in Python. So this is the process. Okay, this is the process of counting. Now let's just recap what we have done. We said that from the library import counter, what does counter do is that it counts the number based on their first appearance from the starting element that will appear to the end element that will appear. Okay, so who appeared first will be counted. So 11 will be counted, 1 will be counted, 40 will be counted, 50 will be counted. This is what counter does, but this doesn't really help me because I want to order them or sort them from the highest frequency element to the lowest frequency element. And what is the function that does this to me? It is the most common method. The most common method is applied to whatever is stored inside the C variable, which is the return of the counter function. That is basically this part right here. So the most common works on this area. It says, okay, this is what is stored inside C, right? So basically take it and please sort them from the highest frequency to the lowest frequency. And this is what is returned by the most common method, and this is what you see printed here. Okay, we just saved whatever most common will return. We saved it inside all frequency, then we printed all frequencies. Okay, now before I talk about the optional content, let's just postpone this for a moment. Okay, now in order to get the single mode, now look closely here. What is the mode of this list? It is 50. And look, if you looked at this list of tuple, the beauty of most common and what does most common do is that it puts the highest frequent or the most frequent element at the start. So the element of the highest frequency is always the first element. It is always located in the first tuple. Okay, and this is the only piece of information that you can use. Okay, this is the most important thing that most common do, right? So with this knowledge that the first tuple contains at least a single mode, at least one of the modes. If there were multiple modes, it contains a mode most definitely. So let's say that we want to access from this list of tuples, we want to access what? We want to access the first tuple, which contains the most frequent element, which is basically the first tuple, which is located at the index of 0. Remember, this is 0. Next element 1, third element 2, fourth element 3. So if you run this, you're going to get the tuple of 50 and 4. Now, say that you want to get the mode itself, where it is, single mode is located. Let's say that this is located in the first tuple. Now, let's say that you want to get the single mode, and we are looking for the element itself. Oh my god, this is so wrong. Itself, yeah. If you want to get the element itself, see, this is the tuple, right? This corresponds to this tuple. So from this tuple, get me the first element, which is basically the element or the number. This is how most common deals with numbers. It's basically returns a tuple, and each tuple contains the number from this list here with the frequency of that number, with how many times did this number appear in this list, right? And this is the case for every tuple that we have. In each tuple, the first element is the number and its count. The number and its count. Okay, so from this tuple, get me the number, get me the element itself, which is in this case corresponds to the mode. Okay, so we're gonna add another layer of access and say that another square bracket, please get me the first element, which is 50, in this case at index of 0. So this is gonna get you 50 like this. And let's say that we want to get not the element itself, we want to know the count of the mode or the frequency of that mode. So instead of getting 50, this is not what you want now. You want the number of times that this 50 has appeared, which is 4 in this case, and 4 is located at the index of 1 of this tuple. So we're gonna change this to 1 like this. Okay, now let's wrap this in a very beautiful print statement, and let's say if string mode is, right, and instead of writing all of this inside the curly braces, I'm just going to put them inside variables, and the mode is at 0 and the count of the mode, count mode, is at 1. So the mode is the mode here, right, and the count of mode is at count mode like this. Alright, now let's run this. So the mode is 50 and the count of mode is 4. This basically maps to the first program. Or not the first program, it's program 6, calculating the mode. But we didn't make a function that does this. So basically to do a function that do the same thing, it's essentially the same. We're just gonna copy some stuff into a function. So let's just take this to the right side and save this as trial, I don't know, trial 5 for example, .py, and let's define a function and name it mode for example. And this mode, of course, you are getting a mode or the mode of any list, right? So this mode function requires you to get or to write to give it some list, right? So let's just give it some list like this. So once you have a list, you can actually import within the function. You can include this inside the function, but I don't really think that this is a good practice. So most of the time, if you have any import statements, please make it outside your functions and put it at the top of your script like this. Okay, now what does this function need to actually calculate the mode? It needs first, yes, you guessed it, it needs to count the numbers of the given list. So you need to count the numbers, which basically is this line. I'm just gonna take this line here. Now we're not working on list 1, we're working on any generic list, which is any list. Now counter will return the count of each element of the list that you're gonna provide with the element with its count, but not sorted from the highest frequency to the lowest frequency. What actually do the sorting is the most common method. So we're gonna take this and put it there, and this is it. By the end of the day, just return what? Return all frequencies. Remember, all frequencies contains a list of doubles, but what the function is saying that it gets you the mode, right? So you can basically return the first double, which will always contain something like the mode, which is the element, and its count, right? So this is what's returned, the first double. Now we can say now that we want to test this function, so let's give it the same exact list that we are working on there. Let's say that count now has 50 has appeared like 6 times or something. And let's call the function and give it list1, pass it list1, and let's print whatever is returned. Now notice that what will be returned is a tuple that corresponds to the first tuple, which is basically the mode and its count. Now run this, you're gonna get 50 and the count, which is 6, right? So you would want to do something like this. You would want to save whatever is returned from this function in a variable, call it for example, it's the same thing, by the way, it's the same thing that I've done there, right? It's the same thing. But now we are saying that we are saving this, for example, in a result, all right? And then we are saying that this result will contain the tuple of 50 and 6. Okay, so we're gonna say that string mode result of 0 and count of mode result of 1, and it's gonna get you the same thing as before. Okay, there is another thing, and instead of doing this, instead of storing the returned value of this function call in a variable, what you can do is actually something like this. You can say you want the mode from the function from the returned you want the mode from the returned tuple from the function call, صح؟ فممكن نعمل I'm sorry about the Arabic part, I just can't control it anymore. So let's say mode and give it something like list1. We are calling the function within the curly braces. Now whatever this function will return is basically the first tuple, right? It's gonna get you the tuple of 50 and 6. So from the returned tuple, I'm just wanting to access the mode, which is the index at 0, and it's the same thing there. So let's take this part here and we will call the function, and the function will return a tuple, and the second element from the return tuple is basically the frequency. So if you run this, it's gonna get you the same exact result. Now before we get to the last program in this video, we will just recap really quickly what happened there. If you want to get the mode or the frequency table, all right, both programs requires you to use a function that is called counter function, and this counter function is not one of the core functions that like the print or the input or the casting functions that we have. So you need to import it from the module that is defined within, which is in this case a module called collections. So this line, that's important. You need to include this line, this importing line. From collections, import counter. Now, prepare some list because you need to count the elements in this list. Basically, when you look at this list, you will know that you have three modes here. We have a mode that is 10, we have a mode that is 2, we have a mode that is 8, right? 10 is appearing 2 times, and 2 is appearing 2 times, and 8 is appearing 2 times. So we have actually multiple modes in this list, right? So basically, what we will do next is use the counter function. The counter function takes any list, and what does the counter function return? It returns the count of each element in a tuple, right? It returns the count of each element in a tuple, but it is ordered by their appearance. Like what appears first gets counted. So 10 appears first, right? So 10 has the count of 2, then 20 has the count of 1, then 2 has the count of 2, then 5 has the count of 1, then 8 has the count of this is wrong. 8 has the count of 2. I'm sorry about this. 8, 2, right? Now, after we store whatever the counter function returns, which is basically counting the elements without any actual order, we will use what have returned inside C, and we will order them from the highest frequency to the lowest frequency using the most common. Most common is the one that orders the counted elements from the highest frequency to the lowest frequency. So after this, whatever is stored from in all frequency and whatever is returned from most common will be something like this. Will be a list of tuples. The first tuple in this list contains the element with the highest frequency. Okay, regardless of if you have multiple modes or not, but just know for sure that the first tuple will always have the highest frequency. All right, it is irrelevant to the fact whether if the next tuple will contain the highest frequency as well or not. The most important thing that this tuple contains the mode inside the index of 0 and the mode count, which is the highest frequency at the index of 1. So let's take the third, which is the last program here now. Okay, so the last program is saying that we should make a frequency table. Now, when you look at this frequency table, you will see that it is using the elements from this list, right? This list contains multiple modes. The first mode that we have is 10 and 2 and then 8, right? All of these elements are modes because they have the highest frequency in this list. Now, in order to make a frequency table, what are we actually creating a table from? If you look closely, you are creating a table from all frequencies. The one variable that we have used here, that we have used the most common method to return these list of tuples. Okay, so whatever is stored in list of tuples is basically, or whatever is stored in all frequencies is the list of tuples that you need to iterate through in order to get a table that looks like this. And basically, this is basically iterating over a list of tuples, which essentially was like the first program, where we needed to iterate over a list of tuples with the same exact fashion. But the difference is this list of tuple we created manually, but in this case, in the program 3, this list of tuples is created automatically by the most common method, right? So you guessed it, in order to get the frequency of each element and to get the highest frequency to the lowest frequency, you need the 3 lines that we have discussed, which is the importing, then the counter, then the most common. So I believe I have this already with me in this script here. That's the counter and that's the most common, and this is the import. If you run this just as a checkup, we have this list right here. But let's work on the list that is provided to you within the example. So I'm going to take list 1 and I'm going to overwrite list 1 like this, and This list of tuples that we are working on right now is basically the numbers, each number, which is 10, 8, and whatever, 10, 2, 8, 20, 5. So we want to put each number of those in a column, which represents the number, and each count of these numbers, we will put them, which is 2, 2, 2, 1, 1, which actually the frequency, we will put them in a column that represents the frequency. So what we are creating a table from is basically this list of tuples that is stored inside all frequencies. This example is really important, guys, because this is basically what you're gonna need to work to do your assignment, your program question in your assignment. So let's say that the header includes something like number and \t frequency. Okay, now we can make some equal signs, but there is no equal signs here, so it's fine. So we're going to say remember we have two methods to iterate over a list of tuples. The first method is to use one iterator, and the next method is to use double iterators or two iterators, since we have two elements inside each tuple. Alright, so do whatever suits you. So I'm going to do the one that I have illustrated inside the lab, which is the first method using one iterator. So for x in all frequencies, and remember all frequencies is the list of tuple that we are working on, which is this list here. And x in this case will represent each tuple. X is each element, which is each tuple. So let's print from each tuple the number, which is at index of 0, and let's print from each tuple the frequency, which is at index of 1. Okay, see that I have shifted this way too hard, so I'm just going to take out 1/t, and this does the trick. This is the same table that we have in this program. Now program 5 with, I believe it's supposed to be program 4, but that's fine. Program 5 or 4 is supposed to be sorting out this table based on the numbers, meaning that the column here needs to be, or the rows needs to be shifted based on the number column from the lowest to highest. So we have 10, 2, 8, 25. We should have it like from ascendingly from the smallest to the greatest, 2, 5, 8, 10. Of course, with each frequency corresponding to each number. So in order to sort these numbers, all are you going to do is something like this. Let's say all frequencies dot sort, and basically what will be sorted here in this all frequency. Let's print all frequency and see, just to make things clear. See, this is all frequency before the sorting, and this is all frequency after the sorting. If you look closely, what have been sorted is not the element to the at the index of 1. It's not the second element of each tuple. The sorting has been done based on the first element of each tuple. So we have ascendingly 2, 5, 8, 10, 20. Right? So this is how sorting a list of tuple is done. Sorting a list of tuples. Okay, this happens based on the first element in each tuple. Okay, so if you run this, you're going to see everything is sorted, and this is the end of lab 6. Now, since just I forgot something, this question is asking you to use functions to create the frequency table. What we have done there is creating the frequency table without using functions. So I'm just creating another trail, whatever. I'm just going to take this to the right hand side like this, yeah, and let's create a function, define it as frequency table, and this frequency table basically takes any list, and we are going to go over everything, but remember the import is done before the function starts, and now we take everything from here and place it there. And if you need to indent, just indent everything so everything is fine. And this is an undesired comment that we don't want to see. All right, so this is it. We don't really want to see these print functions, these print statements. And remember, we're not working on list 1 anymore, we're working on any list. So this is your function. And now let's call the frequency table and give it some sort of test and give it list 1, for example. Okay, so let's call and give it list 1. It's gonna give you the same result. And notice something, that this function, it does not return anything, and this is fine. It only prints, right? So there's no return, so you don't see me doing something like result equals something, because there is no return at all. Okay.